Welcome everybody. This is the final presentation of this project that we had on metamaterials and acoustics. I'm supposed to make a short introduction, so please bear with me. The idea that was behind this project was to look at what has been done in metamaterials with optics, so with electromagnetics. It's been really fantastic in the last few years. So we wanted to know if this success was something that was completely attached to electromagnetism, or if you could go further and consider other fields of physics and do the same kind of things. And what we have considered is acoustics, because in terms of space application, acoustics is really interesting. There are a lot of situations in which we need a control on acoustic and mechanical ways, so it was interesting to look at this. If one looks in the literature, transformational acoustics is not nearly as powerful as its optic counterpart. We will see why this happened in Lucy's talk and in Martin's talk in a very great detail. And the question was then, can we do more? Is that something else that we can add to the kind of data that we have and the technique that we have? So the target was essentially understanding the reason between the difference, behind the difference between acoustics and electromagnetism. It was the development of new approach to transformational acoustics. And in the original proposal, it was suggested to use the concept of analog gravity. This has been done in one line of study, and in the other one is not been done. So there are different alternatives that you will see this afternoon. They're all actually very interesting, although some of them are very, very different between each other. As a last slide, I just wanted to give you a little bit of an idea of what I've learned personally from all these adventures on the idea of transformational techniques and so on. And the first thing is that essentially the main reason why electromagnetism is so successful is that the theory is so-called premetric. And Lucy will tell us a lot about what premetric means. But also the fact that transformational approaches are formalism dependent. So that if you change the way in which you write down your equations, or the way in which you describe the physics that is happening in the wave propagation, you can do a bit more. Not too much, because there are strong constraints, but you can do a bit more with respect to what has been done now. And also that transformational approaches are variable dependent. So choosing the right variable to actually write down your equation is very important. That's another thing that seemed really interesting. And also, of course, the relativity really has some practical applications, so please don't be scared about relativity. It's such a nice theory, we all love it, and we can really do a lot of even technology with it. Okay, that's it, so please enjoy the show.